All right. Today, we're going to start looking at three-dimensional figures. So we're going to talk in the first thing about three-dimensional figures and cross sections. Okay? So, you have a cube of cheese. You know, one of those little cubes. And you take a knife and go, hiya! Chop it right down the middle. Okay? What shape did you just make?
Rectangle. Well, if it was in a square.
If it was a cube... If it was a cube where all sides are equal and you go right down the middle, hiya! No, you're not going to have cubes anymore. You're going to have prisms, but what kind of shape is this going to be? A square. Because what do we know about a cube? All the sides are equal. All the sides are squared. So if we go right down the middle, then you still make a square. Okay? This is still a square. All right. So, what we're going to talk about is how many edges, faces, and vertices there are in each of these figures. Okay, so let's talk about faces first. On this first one, how many faces does this have? Well, it has a front and a back, and a side and a side and a bottom. 5 faces. Okay, how about this thing? 6 faces. 7 faces. 1, 2, 3, 4, 5, 6. Front and back is 7, 8. All right, so we got that down. All right, let's find vertices next. Vertices are the corners. So it's got 1, 2, 3 in front. 1, 2, 3 in back. So that's 6. 7?
8. I was guessing right. Well, how about
1, 2, 3, 4. 1, 2, 3, 4. How about that one? 10. Looks like you guys got a pattern down there. Okay. Edges. How many edges does this one have? Well, it has 1, 2, 3 in front, 1, 2, 3 in back, and then 1, 2, 3 more. 9. 1, 2, 3, 4 on top. 1, 2, 3, 4 on bottom. 1, 2, 3, 4 to connect. 4 plus 4 plus 4 is 12. Do you trust her and her logic?
yes.
I trust her logic.
The faces go by 1, and the vertices go by 2, and the edges go by 3.
Yep. But what if we have some random figure with 30 faces and 36 vertices? How many edges would it have? Well, let's look at that. How do these 3 relate to each other in relationship to how these 3 relate to each other? Add these 2 to get? Add these 2 to get? How many? 11. Minus what to get that? 2. Add these 2 to get? Minus 2 to get? Add these 2 to get? Ooh, because faces plus the vertices, if we add those 2 up, equals the edges plus 2. Or if we take faces plus vertices minus 2, we get edges, right? Okay. But this, you guys just discovered, is Euler's formula. F plus V equals E plus 2.
You should draw that shape for us to see what, so we can see what it would look like.
Let's not and say we did. All right. To make a polyhedron-shaped game piece using a 3D printer, Juanita enters the number of faces, edges, and vertices in a program. She wants the game piece to have 20 faces and 30 edges. How many vertices will that piece have?
48. No, that's wrong.
Faces plus vertices equals edges plus 2. If it has 20 faces and 30 edges, this makes 32, right?
Yeah. 32 minus 20 is
There must be 12 vertices.
48. Because I read it as 20 faces and 30 vertices.
A regular hexahedron is also known as a box. Okay? It has 6 faces and 8 vertices. How many edges does a regular hexahedron have? Well, you could actually count this instead of using the formula. How many edges does it have? 12. Because F plus V equals E plus 2. Here's a regular icosahedron. 20 plus 12 equals E plus 2. So this is 32 equals E plus 2. So the number of edges equals, how about 30? Because we subtract 2. All right, cross sections. Karate chop. So if we karate chop this off here, if we go parallel to the base, the cross section will be the same as the base. Okay? What does that look like it's going to be? 1, 2, 3, 4, 5. What's a 5-sided figure called? Pentagon. Okay? Now, if I slice it down this way, it's going to be a triangle. Exactly. Okay? All right. Here's a regular dodecahedron. Could you draw a triangular cross section? Is it possible to lop off something so it's a triangle? Yeah, if I cut right here, cut this off right here, cut that little corner off with a knife, that would make a triangle. Could I cut something off to make a pentagon? If I am parallel to a base. Okay? If I'm parallel to a base, and so as Donovan said, cut off one section, if I go parallel to this and cut this much off of each, cut it like that, it would make a pentagon. Okay? There you go. If you go parallel to the base, what shape are you going to have? Mr. Gust. I asked a question. What's the answer? You were way off in La La Land there. Yeah. If I go parallel to the base and I make a cross section, what shape do I have? Triangle. If I go perpendicular to the base, what shape do I have? Triangle. Doesn't matter with this one. However we cut it, it's going to make a triangle. If I go parallel to the base, what am I going to have? If I go parallel to the base, it's going to be a hexagon because I have 6 sides. If I go perpendicular to the base, what shape am I going to have? Rectangle. Rectangle. Very good. Okay. This now. I'm going to swing this around in a circle. Okay? I'm going to swing this around in a circle right around this. What shape am I going to have? It's a 3-dimensional shape. This will be a cone. Very good. It'll be a cone. And then if I swing it around this one, it'll be it'll be a weird shape. It'll be kind of like this, and it's circular here. It'll be like a double cone. It's kind of weird. We won't worry about that. Okay. So, let's take a rectangle. Take a rectangle. I'm going to swing it around here. The rectangle is 4 inches by 8 inches. If I swing it around this line, what's it going to make? A cylinder. You guys are so good. It's going to make a cylinder. Okay? What's the volume of the cylinder going to be? We'll find the volume of the cylinder. The formulas are right over there. You're going to be looking over there a lot this chapter. Pi r squared h. So it's pi times, what's my radius? 4 squared times 8. So it's pi times 16 times 8, which is 128 pi. And that's how we write it, is 128 pi most of the time. Unless they tell you to round to the nearest tenth or the nearest hundredth, then you multiply by pi. You push the pi button on your calculator. But if they tell you put it in terms of pi, you leave it like this. Now let's take that same rectangle. Let's take that same rectangle, the 4 by 8 rectangle. And now let's rotate it around its center. What's it going to make this time? It's still going to be a cylinder. But is it going to be as big? It's going to be a lot skinnier. What's the new radius? 2. So the volume equals pi r squared h. So pi times 2 squared times 8. So it's 4 times 8, or 32 pi. Okay? That's the difference. All right.